All right. So, last class you were, well, I guess 2 classes ago, you wrote a paper, or at least a bulleted list, and we're supposed to inspect some alternatives to client-server model. I told you to start with something like Bittorrent. Might be a reasonable starting point. So let's do client-server alternatives. You missed Angry Face Bowling.
Is that your game salad?
It was awesome.
You showed it to me last time.
People were, no, this is bowling. Last time it was the
bowling?
whack-a-mole.
Oh, okay.
Now it's bowling with bowling pins reacting to the spinning Angry Face awesomeness.
It doesn't really spin all that much.
It depends on the angle he hits the pins with.
It's not really scaled right.
That's not my fault. All right, so we'll start with Bittorrent as a client-server alternative. So remind me, what's the weakness of client-server in today's world?
Limited by the upload speed. One server.
Okay, why is it limited?
Because you're limited to the one server, so you can only pull as fast, or you can only download as fast as it can upload. So the more users you get on, the slower it goes.
Okay, so basically we're in a world today where we're constantly using the internet, for lack of a better word, right? So we're constantly using the internet, and if we're pulling stuff from a single server, and there's 500 of us trying to pull down data, that server's upload is being divided amongst many of us at any point in time. Not a great use of their bandwidth. So that means that as you're surfing the internet, the person who's next to you, if they visit the same website as you are, potentially they're slowing down your experience. Kind of not what we want, right? So now that doesn't mean client-server doesn't work. There are some alternatives to it, and hopefully you stumbled upon some of these that still follow somewhat the client-server model. But how does Bittorrent work? Let's start with that. How does Bittorrent solve the client-server problem?
I guess there's no central authority in charge. It's just peer-to-peer network, so you're sharing resources amongst a very large group of people.
Okay, and how are those resources shared? So if we're going to create a bunch of people, I'll just do 4. So here's 4 people, and there's one file. This is, well, no, I probably need a, this would be good enough.
Like a box. You change it.
Do I? All right.
Or you could leave it as a box and
Change the other ones?
To circles.
Can we make it a goat?
Well, what happened here? Okay, do you know what DOS stands for? No. It's desolation of smog. Likely a movie people were stealing. Now the second one's out already, right? Yeah, but so this was
definitely still people stealing it.
People are still stealing this one in preparation to steal the second one.
It's not stealing. It's borrowing.
I don't think that's true. Yeah, I'm pretty sure that's not true.
Somebody stole it with a camera in the movie theater.
I got you. You're an innocent bystander.
Yeah.
All right.
I just happened to be getting this random virus.
Makes sense. Okay, so here's our movie. Here's our movie that is out on the internet somehow. How does this get put onto the internet through Bittorrent? This is the guy who stole it. So he wants to get this out on the internet. How does Bittorrent work?
Okay, so he would start hosting it per se, and then everyone who downloads it is a seeder or a leecher. Then when they start downloading it, they can also choose to, give some bandwidth, hosting it as well.
Okay, so
That
so
would
this
probably
guy
be
has the
fair.
file, and he's basically said, "I'm choosing to share this with the world." Okay, and to do that, he's probably also then going to distribute a .torrent
Yeah.
file that people can. That's how they find him, right? Okay, because he is sitting out there, possibly behind a firewall somewhere, right? So there's got to be some central authority. If you look, there's a couple of different kind of torrent hosting places that you can jump to, and they'll direct you directly back to him. But in any case, he gives information of how to get to him wherever he is on the internet. So then this guy comes along. He says, "Oh, okay. Well, I want to start downloading. I want to start downloading from this guy." Okay. And so now this guy's serving it. He has the entire file, correct? Now this guy's going to start downloading it. And at this point, he's using this guy's entire upload bandwidth, or as much of it as the guy's willing to give, right? And while that's happening, he's beginning to build his local copy of Desolate. Am I phrasing? I always wonder with shapes if I end up phrasing without phrasing. All right. There. Just pretend like this is a mini version. I hate all of you. All right, so he's building up his own local copy of the movie, right? This looks kind of like the thing from Star Wars that Darth Vader flew in.
TIE Fighter?
Yeah. Doesn't it?
Yeah.
Change your movie, man.
Which one?
All of them, because you can't stream it anywhere. That's probably a pretty popular one to download. So we're stealing this one down.
But they don't. They generally don't package all of them together very often.
The last 5.
The last one.
This guy did. Okay, so shut up. So anyways, we are building our local copy of Star Wars here that we're downloading from this one source. Okay, so if nothing else happens, this is essentially a peer-to-peer network, right? And do we have any sort of real benefit at this point when the BitTorrent network is this small?
Nope.
No benefit at all. In fact, probably whatever program he's using to share his torrent is likely limiting how much of his upload bandwidth can be taken. So he's not even fully functional at this point. Okay, so what happens next? So this guy wants in. How does he get in on the action?
The torrent file specifies some server that knows where all the other people in the group are,
Okay.
and so he.
So we have a top level dude here. This is Mr. Torrent. Okay. All right, it's Mr. Torrent. So Mr. Torrent knows about this guy, and then he knew about this guy. Because Mr. Torrent was the host of that torrent file. So when we double-clicked it and started doing it, it told us how to connect to this guy, which then allowed us to establish this connection. Right? So now this guy comes along, and he wants to start downloading. So he's going to go talk to Mr. Torrent. Okay, and what's Mr. Torrent going to tell him? He's going to tell him to connect somewhere, right? Well, in a typical client-server model, this guy would have connected right there because this is the main server of the information. But as we're watching this, we see that this guy has the entire file, and this guy has a portion of the file. So, who does this guy connect to?
They're both.
Both of them. So he's going to connect there, and he's going to connect here. What happened? All right, so he's connecting to both of these places. So now, who determines what information he gets from here and what information he gets from here? Would it be in this guy's best interest to get, let's just use it as the, divide the movie up by minutes for this example. Would it be in his best interest to get minute number 1 from here and from here? Or is that wasting the bandwidth that's now been made available to him? Wasting. So he'd rather get minute 1 here, minute 2 here, minute 3 here, minute 4 here, something like that, right? Okay. How is it determined which part of the file he gets from this source, from here, and which part of the file he gets from that source?
Members of the internet convene and decide amongst themselves which parts can be.
Which file is not being used on each side of it. So if like minute 1's in use by that user or is being sent to the one user while the other user is trying to connect to it, the other or that user is going to bounce it from get minute 1 from the other. That way you don't have 2 people trying to connect to this and get the same portion of it from one source.
Okay, so this guy down here, when we draw these little pictures like this, you can subdivide this up into, how many minutes long is Star Wars? 120? Just say it's right, 120. So we're going to divide this guy up to 120 little buckets. Now the job of the Bittorrent client here is to make sure every one of these 120 buckets gets filled up. That's his job. Okay, so the Bittorrent client's going to be looking at the current file, trying to fill that puzzle. And right now he has 2 sources to go out to. So he's going to come, so let's just say he happens to check this source first. He's going to make a request to this source. I need minute 1. So and let's say this source says, okay, we're good to go there with minute 1. This is going to be awesome. Watch this. Boom. All right, we got an active channel.
Impressive.
It's almost as good as that bowling game now, isn't it?
See, this is where I'm
This is where
Added value.
this is the added value. Okay. What I need to do is one of those, the little Jesus fish. Then it'll be Christian worldview. I talked about it. Counts. All right. So in any case, at this point we have an active connection. So this guy's going to say, okay, we are expecting minute 1 to come from this source. So we're not going to go out and ask for that again. Okay, unless for some reason something goes south here. That is, this person decides to stop seeding because he's recognized that he's finished downloading his file. Okay, but that never happens in BitTorrents. Okay. Everybody is altruistic with BitTorrents. Once they finish stealing their movie, they keep it up for another 48 to 72 hours and make sure that everybody else can successfully download it as well. Okay, so now this guy's also going to reach out because he has a collection of known seeders, people who are seeding the file. So he's going to reach out and say, okay, I want minute 2 from you. So this guy's going to then activate. So now he's pulling in minute 2 from over here, minute 1 from over here, and continually building up his own local copy. All at the same time, his local copy is now available for seeding. So now, as he's picking up bits associated with minute 1, although in our example here, we've only broken it down into individual minutes, after he has minute 1, he can start seeding minute 1. Does that make sense? So that when this guy comes along and joins in on the connection, he's going to open up a connection to the original guy. Connection to the second guy, well, third guy, I guess. And a connection to the second guy. And he's going to start his own requesting. Now, depending on the BitTorrent client, there's usually a default for the maximum number of connections you can establish at once, and also the amount of your bandwidth. So, you can see pretty quickly if this is a really popular movie and we get 1 million people all connecting, you probably wouldn't want to have 1 million people all connected to every other one of those people. So you're starting to take up a lot of network resources then, which then slows down the experience for everybody else. So what you're trying to do is you're trying to take the size of the file and spread the burden across the internet. Okay, so maybe this guy is providing regionally a bunch of the movie to these people over here, where this guy is regionally providing it over here. But initially, all of these guys were reliant on each other to start duplicating the one source of the movie to multiple sources of the movie. That makes sense? So that took away the weakness of having the download speed limited by this guy's upload speed. So that's roughly BitTorrent. let's say. Okay, so that's what's good about BitTorrent. What's bad about BitTorrent from a technology perspective? Not that, I hate leechers. Get their movie, they stop seeding, and then my speed goes down. We could say that's a true negative, right? The speed of the network is dependent on the number of people that continue to participate on the BitTorrent network for this particular file. And since human nature is that once I get what's in it for me, once I get what I want, what's my motivation to continue to participate? You might say, well, my motivation to continue to participate is I would like to be the recipient of the next file that I'd like to get, so I want to support this illegal network of movies. Right? Questionable. This questionable network. I want to support this questionable network. Right? Could be.
Some movies on there are illegal.
Most not.
There's a few.
The questionable network of possibly illegal movies.
It's only illegal if you're proven guilty.
I don't think that's. I don't think that's true.
They cut that disclaimer off the front of all of them, so it's the whole federal thing where you can't share it. That's never on it. Doesn't that make it legal?
Oh, the
Simple video editing.
yeah. All right. So, besides that, is there any other weaknesses you see with BitTorrent? Go ahead.
Should the file be altered by have more chances for someone to upload something bad?
Okay, now you could have that. So, BitTorrent would be a relatively... See, they do have a security protocol, so there's a whole language that these clients speak with each other to establish the BitTorrent connections. But let's just assume it wouldn't be that difficult for this guy to decide, you know what, I'm going to replace my copy of Star Wars with something else. And I'm going to start seeding that to people. Okay? And so now you think you're getting Star Wars, but what you're actually doing is getting the, I don't know, Polish version of Barbie the movie or something like that. Was that phrasing?
No.
Somebody's supposed to wake up. That's an alarm. In the future, if you set an alarm for class, you want to set it for before class time.
One limit you have with it is it
Which
does
one?
take the client on the
This one? No.
each end of it to put the file back together.
Okay, say that again.
It's reliant on a client or on a program at each end, a piece of software at each end to reassemble the
Okay. All right, so one issue is that we are breaking that file up, just like we do with TCP/IP, where we split it up into a bunch of individual packets. But we are reliant on this piece of software to put it back in the right order. Wouldn't that be kind of funny if you just finished downloading Star Wars, but it was like, Frankenstein's monster? It's kind of, if we had the whole minute thing and the minutes were just randomly jumbled apart, so you had to watch 120 minutes of Star Wars in random order.
That would be hilarious.
Fantastic.
It actually would be kind of good.
Can we make this happen?
That would be kind of good. So there is a level of that you are counting on all the other people in here to be sharing what they say they're sharing. So your files, all this guy's trying to do is he's trying to fill minute 17. So if this dude tells him I have minute 17 and he's sharing it to him, he's taking his word for it that it's minute 17. Make sense?
I get really bored one day. I'm totally doing it.
So every day?
What, you're splitting up Star Wars into 120 minutes and then randomizing it?
It's copyright infringement.
Is it if you do it for yourself?
Well,
Oh, I'd post that.
yeah. Come on now.
All right, so any other weaknesses you see with BitTorrent? Where is, based on your experience, when you go to not that any of you have ever used BitTorrent for anything illegal. When you go to download something with BitTorrent, let's say you happen to be looking for Star Wars the movie, and let's say there's 30 sources for it. Which source do you pick?
Well, you pick the one with the most.
Most what? Most seeds. Those are the most people who are giving the file, correct? What does that mean? If there's something that's giving there's a lot of seeds, what does that mean for you? Faster download. What's the torrent you'll never pick? The one that has 1 seed or 2 seeds?
1 seed and 0.
That initial guy who's sharing?
1 seed, 5 liters.
Yeah, 1 seed, 5 liters. So you'll never pick that, right? So right off the bat, you have an elitist type network where most of the sources aren't acceptable networks for downloading the content you want. They only become acceptable networks after all the other ones dry up. And somebody decides, okay, this piece of crap network over here now, we're going to turn that into the next good one. Right? So everybody double click on this one. So now it goes from 1 seeder, 5 liters to 500 seeders, 10,000 liters, whatever.
1 seeder, 500 liters.
All right. Does that make sense? So that could be a weakness. There isn't a guaranteed, or there isn't even a consistent quality to torrents. And if you go online, a lot of times the torrents that are good quality are the same torrents, because these are the ones that post their links on all the different sites that you shouldn't be going to. That kind of stuff. So they become popular. So it becomes an inconsistent type technology, and you kind of get into this situation where you know who's the right person to download from and who are the bad people to download from. Not even from direct identity, but just from the statistics of the network. Okay, so we've become picky about how good the network might be before we even click on it. It's kind of funny, I guess. All right, so BitTorrent's good in that it shares the burden of the file across a big network, hopefully a big network. Where it's bad is there's a lot of moving parts where things could break down. Okay, we do have some technologies that go along with that, though, that kind of help us make sure what we got is what we should have gotten. A lot of times with a torrent, the first file you download, is certainly with legitimate torrents, is going to be something that's going to have the MD5 hash of the final file, so that you'll have this hash value that you can now, once you have what you believe is the final value, the final file, you can hash it, and as long as those match, you got the original. Okay, so that means that you didn't get that Barbie movie mixed in with Star Wars. Well, at least very unlikely. It'd be very unlikely that you had a 75-minute Barbie movie that hashed to the exact same value as the 120-minute Star Wars movie. Not impossible, but highly, 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 highly unlikely. All right, so what else do we have besides BitTorrent? So BitTorrent, we're going to call this guy a distributed peer-to-peer network. Distributed peer-to-peer. What else did you find? Oh, let's go back to some historical ones. Anybody put down like Napster? It's NAP like that, right?
Yep.
Okay, so Napster from a while ago. How many of you have used Napster? How many of you have never heard of Napster before this assignment?
I'm really old right now.
Napster was kind of the original way of stealing music.
That's what I grew up with that.
Okay, Napster was the original. Now, Napster would have been a true peer-to-peer network. So we dropped to distribute it. LimeWire was a lot later than Napster. Okay, so a true peer-to-peer. So let's look at that.
You can on Napster, you can literally view all the files on somebody's computer if they have them shared.
All right, so we have Napster. Get our multiple dudes out here. All right. So this guy has our file. Whoop, hello. He has our Star Wars file. All right, and what's he going to do with it? It's like destroyed, I think, a nerve ending in my finger when I picked that up. I was holding it, and I almost just like threw this like that. That would have been awesome. So how did Napster work? So here, this guy comes along. I want Star Wars.
This actual dialogue.
This just got creepy. All right, so he wants Star Wars. What does he do? Who does he talk to? This is some kid who has Star Wars in his computer in his living room, right? You know. Oh, well, he said he was 18. So, still creepy, not phrasing. All right, so in any case.
Star Wars. Right.
Star Wars.
Did you tell me you had candy?
So we have Star Wars. So this guy wants to share Star Wars, okay? This guy would like to get Star Wars. So he sits down on his computer and he's looking to procure the movie Star Wars. And he wants to use Napster to do this. How does it work? Do we have a Mr. Napster? Okay, so we have Mr. Napster. And what does this guy do to let Mr. Napster know about him?
Sure. File via Napster.
Okay, so Napster is a client. Well, it's a client and server. So you'd get the Napster client on your computer, and you'd have the Napster server out here. So right off the bat, this sounds client-server, right? All right, so this guy,
You request it to the Napster server, and then it direct connect you to the client.
yep. So this guy would say, okay, I have a file on my local machine that I want to share. He would let the Napster server know this. This guy then connects in, and he's able to look at the Napster server and see what, kind of browse like you're shopping, see what files are available for download, right? And he sees, oh, there's Star Wars there. So what happens is Napster, oh man, am I going to be able to, this is a very, ooh. Got this. Napster's going to connect those two connections. It's going to connect those two things together. Why did Napster do that instead of this? Bittorrent works the same way. Mr. Bittorrent had to do what we're doing here. So why did Napster do that instead of just saying, oh, you can connect to the guy right here?
Which connections are happening or who are the numbers?
Okay, there might be some benefit to knowing about how many people are downloading from a certain thing. It's fine. But why did they make the connection right here? So if you've dialed in and told me you're willing to share a file, and you've dialed, I'm Mr. Napster in this example, and you've dialed in saying you want to download Star Wars, rather than me just telling you about him, I'm going to connect those two connections. Why? Let's take a guess at what this guy's IP address is. Let's say it's one of those. A non-routable IP address. Okay? Even if it is a routable IP address, he might be behind a firewall, as is the campus here, as is the situation here on campus. So if we look at I just learned this new trick. If you hold down the Option key on a Mac and then click on your Wi-Fi here, it gives you all this information about the network you're on. So my IP address is 172.31.228.200. Okay, so that is, I can tell you, that's not one of the non-routable IP addresses. That's a real, true-to-life IP address. But if I was off campus here and I tried to remote to this computer, it would not work by IP address, because the campus's edge router is going to block that incoming connection because I'm behind a firewall. That router is the firewall. So anything that's coming internally that it hasn't opened a port for in the firewall, that it doesn't just let those through, it's going to say, this doesn't work. Okay? The funny thing is this is why some of those things like Log Me In and TeamViewer, this is why they work. They work just like Napster worked. So when we finish talking about this, it'll make sense. All right, so this guy has a non-routable IP address. So whether he has that or if he has an IP address like I have here, where it's behind a firewall, in either of those cases, I can't directly get to this guy. I'm either going to be blocked by a firewall if it's a real IP address and he's behind it, or this 192.168.1.213 is not unique on the internet. There's millions of those. Okay, so I can't actually find him by that address. This is for a network address translation situation inside of his house, a little home-based network. All right, so Napster's going to connect the dots like this. Why? This guy has opened a connection here. This guy has opened a connection here. Two connections that are both open. Both of them, this guy has gone through his firewall because he opened the door. This other guy's gone through the firewall because he opened the door. Firewalls let stuff out, not back in. Make sense? But we're holding that communication channel open. So if we draw in our firewall here, that's what a firewall would look like, right?
Are you gonna make it fiery? Like red and
Obviously.
first?
Wait, oh, where's my
Phil.
Oh yeah. Shouldn't I have better colors than that?
Oh,
Blue and
geez.
green.
What's up with that?
Yeah, what's up with your color scheme?
Oh yeah.
Oh, wait, background. Okay.
I'm a leprechaun.
Now you can click on the little.
Still creepy. All right.
You
So,
can click on the little circle thing and change the color.
no, we're fine.
That's not
This
weird.
is fine.
It's not weird.
Okay, so this is our firewall. Firewall does not let stuff in. Yeah, we're getting maybe close to phrasing. All right, so firewall does not let stuff come in, but we can open a connection out. So this guy's open a connection out, this guy's open a connection out. Mr. Napster then connects those two connections to each other. And we saw this in class a couple classes ago when we were creating server sockets and client socket connections. If we have two incoming socket connections, there's nothing that keeps us from connecting those together. Okay? Tim was laughing. I haven't decided if I've done something funny or if he's continued on my arm movements into something else.
Nope. We hit the Christian review. We're not gonna break it.
No.
I think it's already been shattered and crushed into pieces and ground into the dirt.
Because what I was thinking about was that season finale of, what's the name of that movie? Not movie, the TV show. The startup company.
All the catch fire.
No, it's on
Silicon Valley.
Silicon Valley.
Oh,
Season finale of that. If you haven't seen it, that might be something outside of class.
Don't go there.
Yeah. It's really funny, but it's definitely, and it's actually not classroom appropriate for like totally other set of reasons. Not the usual set, but it is funny. All right. So in any case, Mr. Napster is going to connect these two socket connections to each other so that they can communicate with each other. Because what that effectively does,
What if they're not the same height?
is this. Okay? But this guy didn't have to directly communicate through the firewall here. All right? So this actually bypasses a major issue that existed in networks for a long time. Okay? Now, I don't like to brag, but I was solving this problem way before Napster. Okay, when I was an undergrad, we had a problem on campus very similar to this, where between multiple dorms, we couldn't share files with each other.
Can share homework.
No, we were trying to share other things. Okay. Okay. But we had we had a server in the middle of campus called UXB. It was a Unix server. And UXB was accessible from everybody. It was not behind a firewall. So what we did is we wrote a program, and by we I mean me. Because my buddies were not good programmers. Compared to me, they were better than me. Okay, so
Digging that hole.
so in any case, we put a server up there that we would both connect to, and that would put the connection through. So I wrote Napster way before Napster came out. Years before Napster came out. It was text-based, but, who cares? And they took all the credit. They got sued and everything. They were in the headlines.
That's the way to do it.
I wonder, did Mr. Napster ever actually make money, or did he just lose everything?
Well, he sold out
Yeah.
when he made it legal.
Because wasn't he, Mr. Napster was part of the Facebook founding. Yeah, Mr. Napster was, what's his name from NSYNC?
What?
I'm having problems coming up with names here. What's the Timberlake? Justin Timberlake. Justin Timberlake was Mr. Napster in the movie.
Oh, and social media.
Yeah, in social media.
Oh, yeah.
See, so he was Mr. Napster. So in any case, this is what they did here, where they connected these two sockets together so we could avoid having to get through firewalls. This was a major hurdle for years. That even though you had an internet connection, people couldn't get to your computer because of that firewall. All right? So now this guy is directly downloading from this guy. Similarly, if this guy said, I'm willing to share this file with multiple people, now what do we have? He would open up additional communication channels with Napster, and then additional people could, let's get the whole rigmarole here. Additional people could communicate in, and Mr. Napster would hook those connections up as well. So now this guy's choosing to share his bandwidth, his upload, amongst, in this case, two people. That makes sense? So it would be his Napster client that he would set up to decide how much what his upload bandwidth was that he was willing to share, and across how many people is he willing, how many simultaneous connections am I willing to handle?
This is just a quick question for clarity. When you say that the firewall was preventing the connection from going through, are we talking about the firewall on Windows, or are we talking about the firewall on the router?
Well, we could say both. I mean, really it was the firewall and the router.
Okay.
Okay, so firewall and the router would be like, I'm going to stand on the other side of that door over there. Okay, and it's a one-way door. I can only open it. Okay, you're going to run at that door, and no matter how hard you run, it's going to eventually knock you out.
Can we watch this?
Okay? It's like we got to demo it. So that's how a firewall works. I can open the door and let you out in the hall. But as long as I am keeping that door shut, you can't get to me. All right, so that would be the physical firewall. Now, even things that get past the physical firewall, your software-based firewall on Windows could then also break it. So this computer is running Windows, and it could say, oh, all incoming connections on a certain port we're going to block. That makes sense? All right, so that's what the physical firewall problem is. All right, so, but this was still a peer-to-peer network. So ultimately, this guy was downloading from this guy. This guy was downloading from this guy. And when you really look at it, what is the situation? That's a client-server network. We're just moving around who's the servers. So this guy might be the server of Star Wars. This guy might be the server of Desolation of Smog. Right? It's Smaug. I saw that dragon was on the Colbert Report.
Mhm.
It's a good episode. Do you think it was real? It looked real.
I know it was.
I don't know how much of this is true, but I believe it.
I just want to know how they got it in the building. No way it's right in that.
Okay, so what's good about the Napster protocol? Huh? Okay, and in that day, that would have been a big perk because we weren't really getting past firewalls. That was a major issue for people who were just trying to share. Even like I was using that example on a campus where, I know the person I'm trying to communicate with. He was sharing with me over a phone call. This is my IP address. Okay, and I'm sharing this file. And the dude, his next door neighbor, could see the file. But I couldn't because I was in a different dorm or at least on a different subnet, and there was a firewall between us. Because there was a router sitting between us, I couldn't get to his files, but his neighbor could. So it wasn't that the university innately didn't allow file sharing. It was dependent on where I was topologically on the network, whether or not I could get to his machine or not. Okay, so we had to agree on a centralized place, a la Mr. Napster. Okay, but way before Mr. Napster was my awesome program. Okay, that we could both connect to, and then that would actually create the connection.
Did it have an awesome name?
Yeah, it was called Bitbaker. Actually, that was a pretty good name. That was way, way, way before Bittorrent. Bitbaker, that would have taken off. Man, we should have marketed that. It did have an. I forgot about that. Now you just depressed me even more.
Just been doing that all day.
Where did you put the program?
Huh?
It couldn't have been on your computer, otherwise you'd have had trouble finding it, obviously.
No. So we had Mr. Napster in our network was a server called UXB. It was a Unix server. So I had a shell account with UXB. I had as a student, I would log into this Unix server to check my email. So I would be out here.
Just took over part of the school server.
I wonder if that's still up. IP address is still up. Actually, it's probably campus blocking this,
They're like, what are you
just like they block trace routes and stuff. They're blocking the telnet protocol. Doesn't matter. But in any case,
just use TeamViewer, do it from your computer at home.
it's not that important. So in any case, that's how I would check my email. I would remote into this Unix server and I would use the mail program to check my email. We didn't have graphical email then. My machine was at the time I was probably running Windows 3.1. I'm guessing. So we were email was just kind of a new thing. So I took advantage of that and I wrote a program that ran on this guy that we all could get to because this guy was not behind a firewall. Even though my dorm room was, but these two guys were in the same dorm, so they could talk to each other, but they couldn't get to me. So we all connected to UXB, and UXB connected the dots like this. Does that make sense? All right, so what Mr. Napster does, well, what Napster does, we're just going to, for now on, every technology we just throw Mr. in front of. Okay, Mr. Napster, what he did is he turned a bunch of individual clients into a bunch of client-server networks. That makes sense? But it became somewhat of a distributed problem because chances were, at least back then, you didn't have millions and millions of people trying to get at the same file. Or they might have to wait in line. For instance, if I wanted to download Star Wars from this particular Napster user, if he had a 5 connection limit, and he already had 5 connections, I could queue to wait till it was my turn. Okay, but I would only be able to start downloading once one of those connections opened up. That makes sense? And then the Mr. Napster server in the middle would hand it off. So at the heart of Napster, you still had a client-server model. But this client-server model wasn't having to worry about that upload bandwidth because it wasn't serving files. This guy was just doing the work of wiring connections together. So very low bandwidth type of stuff he's doing. High processing, but low bandwidth. Understand the difference? Okay, so this guy's not serving Star Wars through his connection. This guy's serving Star Wars from his connection to this guy's connection. So this guy's download, this guy's upload. At that time, Mr. Napster's out of the equation. All Mr. Napster is doing is playing matchmaker. He's taking internal incoming connections and matching them up with other people who are willing to share files. So still client server, but we distributed it. All right, so that's Napster. What other technology do we have? Actually, before we do that, let me ask you this. As a network professional, since we're kind of running low on time, let's say that you wanted to block Napster. What would you do? Huh? Kill Mr. Napster? Yeah, we put a hit out on this guy. So that's one way. We could go and we could actually take offline the one centralized Mr. Napster server. So that's one way we could block. Okay, but typically network administrators are not in the killing business.
Denial of service attack on that server.
Well, that would be maybe how you would pull it off, but this is before denial of service attacks existed. So how could you take care of making sure that these guys couldn't utilize your network through Napster?
Block the Napster IP.
Okay. So, well, let's talk about that a little bit. You said block the Napster IP.
Block the outbound connection.
Well, so you could do that. You could block the outbound connection. Okay, so when this guy says, I want to share information on the Napster network, he has to open up an outbound connection to Mr. Napster. At the firewall, we can block that IP address. Right? So then what's Mr. Napster going to do? He's going to start moving around. Right? He's going to keep changing IP addresses, kind of trying to stay ahead of them. So the network administrator would block IPX, Napster would move to IPX plus 2. Block IPX plus 2, so on and so forth. So it became this moving target where Napster would work for a day. That make sense? Well, what else could we do? So that's blocking the outbound communication. What about the inbound? So Napster had to work on a port above 1024 since those are reserved by the operating system. So in the early days, Mr. Napster used a static port. I don't remember what the port was, but let's say it was port 4000. So couldn't this firewall just say any traffic coming in on port 4000, we would block? Mm-hmm. Yeah. So even though this guy could open up an external connection to Mr. Napster, and Mr. Napster would actually connect these two dots, the firewall would block any communication coming in on port 4000. All right, so next time, and I'm sure as you help me complete this list, we're going to add some other peer-to-peer networks which learn from Napster and try to become a little bit more of a moving target. That is, shifting IP addresses, shifting port numbers. So basically trying to stay several steps ahead of the network administrators. All right, I'll see everybody on Friday.